Hi, welcome to Lesson 13G, Relationships Between Lines. The goal of today's lesson is to determine how lines interact by examining their equations. So if we take a look at the situation where we have a pair of lines in a plane, we know that, that lines can be parallel, and therefore if they're parallel, that means two lines in a plane would be parallel and distinct. And in this case we have 0 points of intersection and therefore 0 solutions. Another way that two lines can interact is if they're intersecting. So there would be 1 point of intersection and therefore one unique solution. Now notice that these lines do not have to be perpendicular, and actually they will very rarely be perpendicular. As long as they're not parallel, they will intersect somewhere. And in a plane, the last situation is if we have lines that are, as I fold this around, have lines that are coincident. That means that the two lines are parallel and they pass through the same point. In this case, there are infinite points of intersection, and therefore there are no unique solutions. Those are the three situations that we're going to be looking at. And we're going to examine the direction vectors of lines to see if they're parallel or non-parallel. And if they're parallel, we can then decide, we can see if both equations go through the same point or not. If they are not parallel, then we're going to see if the parameters are such that the two lines intersect. Well, actually, in a plane they will intersect. So definitely they will intersect if they're in a plane and they're not parallel. So we look to see if they're parallel by looking at the direction vectors. Then we look to see if they're not parallel otherwise and find the point of intersection. One other thing that we have to take into account when we talk about lines in 3 space, so we can have parallel, we can have intersecting, we can have coincident in lines in 3 space, and if there happens to be lines in 3 space that are not parallel and they do not intersect, those are called skew lines. So I'm not sure if I'll be able to draw this adequately. So if I draw the three-dimensional Cartesian plane here, if we have one line that's, I don't know, over here, and then we have another line that's up over here, well, it's still not, I can't really show this without perhaps some graphing software, but this line is, let's say it's down on the yx plane, and this line is above the yx plane. We would see that they're not parallel and they won't intersect because they're skew. Okay, so in that case we would just determine if we would try to find out from their equations if they were skew or not. Okay, by first looking at their direction vectors to see if they're parallel, and then noting that they're not parallel, or if they're in the situation that they're not parallel, then determine if they intersect or not. And if they don't, then the parameters would be such that the lines do not intersect. So there would be no common point of intersection between them. So that's basically it. We're going to be looking at a few examples in class tomorrow just to see how all this works. And in the meantime, take a look at some examples in your textbook and peruse these questions, these practice questions here, so you can see what you're going to be dealing with tomorrow in class. And thanks for watching, and we'll see you in class.